the plan, just to remind you what you have to know for the quiz. We give you one question on the reduction of the order. Remember, it's straightforward. Make sure you have that formula. Y1 would be given to you. You have to find the Y2 for us. The point is, when you want to determine P of X is the most important part. The first thing to do with this type of equation, you have to divide by coefficient of the Y double prime. Otherwise, the integral would be so complicated that you won't be able to do it. So make sure to do it, okay? And so that would be one question. We give you a couple of homogeneous equations to solve. All straightforward. Okay, there may be second order, the third order, the fourth order. Okay, at least two of this, but it may be 4 equations to solve for us. So that will be homogeneous. Then for the undetermined coefficient, we give you one question that you have to find it. I'm going to do this first part for you. You see it. It takes time. I know that it's going to be just a single term, just to test it. And we give you one question. All of them would have 2 parts. We give you an equation, and we just ask you to find form of the YP only. In this case, you don't have to solve it. You have to just give us what is the form of the YP, and you're done. Okay. So I'm going to do one of these coefficient first for A. See how we're going to find it. Okay, and then you have all of them are available, and have a look at it yourself. Okay, so this would be 4A. They just ask you to solve the equation. Okay, and they give you the method. You have you have only one method, so we are not going to worry about it. Because there's going to be another method after the quiz. We talk about it, quite interesting method, when the coefficients are not constant. We do something, we call it variation of the parameter. Both of them are going to be used at the end of the, and the end of the course. When we get to the Laplace transform, we would like to solve the system of the equations over there. Exactly the same thing, but we have 2 differential equations at the same time. But we combine this method with a little bit of linear algebra, and that would be the interesting part of your final exam. Okay, that's why we usually, on the final, even we give you one question, just solving this solution and determining coefficient and the variation of the parameter to remind you that you have to know those, nothing else. So far, whatever you did is not going to be repeated on the final. But these 2 methods, we repeat it on the final too, because we need it. Okay, so let's give you an idea of what we need to know. There you are. Solve each differential equation. Solve each differential equation, or the one that I'm going to solve. Differential equation. The 4A is this one, y double prime, okay, plus 3y prime minus 10y equal to the 6e to the 4x. You recognize it that this is a linear differential equation with the constant coefficient. First thing to do, you have to do the homogeneous one. You have to find the YC and the YP. YC plus YP is the final answer. So solution. Solve the homogeneous one first. Solve y double prime plus 3y prime minus 10y equal to 0. Characteristic equation. R squared plus 3r minus 10 equal to 0. Make sure you don't make a mistake here. By factoring can be done. Numbers. You need 2 numbers product of 10, difference of 3. So it's going to be r plus 5 times r minus 2 equal to 0. It doesn't matter which one I'm going to call R1 or R2, but I'm going to call the R1 to be a -5. The R2 is equal to 2. I have 2 distinct solutions. So the general solution is going to be YC is C1 e to the -5x plus C2 e to the 2x. This is the first part, 50% of this problem. Now the question is YP. You bring the R of X. R of X is a constant times exponential function. So we change it to the constant polynomial. That would be y of p. So y of p is constant polynomial. See, just A1, it doesn't matter, B, C, D. So, yes, question?
Isn't it R plus 2 R minus? Or never.
No,
Wait.
no, it's not.
Oh.
Okay, you want the product to be 10, the sum to be sum with positive. Okay, so the yp, a constant polynomial, we call it A times e to the 4x. You check for the duplication term. There is no duplication term. Because you have e to the 4x, over here you have e to the 2x and e to the negative 5x. So this means it's done. Okay, so you don't need, so we check it. So check it for yourself. Check. So that's a good one. Now you have to find the a. In order to find the a, you have to substitute yp and its derivative into the original equation. Because you claim that this is going to be a solution of your equation. Okay, so go for it. Find the derivative. So the yp is equal to the ae to the 4x. So differentiate it. So exponential function is going to be 4ae to the 4x. Okay, second derivative. The second derivative, you get another 4. 4 times 4 would be 16 ae to the 4x. That's it. Take all of them into the original equation. The original equation, y double prime, is 16. You see, original equation is this one. So you substitute, this is original equation. So we substitute, we get the y double prime, which is 16ae to the 4x plus 3y prime, 3 times 4ae to the 4x. Okay, minus 10y, 10ae to the 4x. And this is equal to the 6e to the 4x. That's it. And drop all the e to the 4x. Because e to the 4x is a non-zero number, and you can divide it. You can divide it later or just divide it now. You see? Leftover is one equation that enables you to find it. So the leftover, this is going to be 16a. This is going to be 12a. This is going to be minus 10a equal to the 6. Simplify that, give you 218. It's going to be 18a equal to the 6. So a would be 6 over 18. A would be 1/10. That's it. So your yp is going to be, this is your yp is ae. A is 1/3. 1/3 of e to the 4x. That's it. That's a yp. Now to give us the final answer, y is yc plus yp. I'll substitute. Remember your yc was c1. So we get a c1 e to the negative 5x plus c2 e to the 2x plus 1/3 of e to the 4x. And you're done. This is, the way we are going to solve it. This step is done. Okay, any question? So this is going to be one case that we're going to have to give you something with the repetition. So I do the part C on this number. Any question? So this is the way we're going to do it. So let's see one with the repetition. It's a 4C. We have the solution of all of them. So it's an exponential function, So let's see what is special about this one. We want to solve this equation, y double prime, 10y prime, plus 25y, equal to the 14 e to the negative 5x. This is the one. Again, solve the homogeneous one first. Solution. Homogeneous, solve y double prime, 10y prime, 25y. What's characteristic equation for this one? R squared, okay, 10r, 25. Easy to factor. Only r plus 5 times r plus 5 equal to 0. So you have r equal to the -5 and -5. It's a repeated solution. Okay. So what's going to be YC? For one of the solution, you get only, okay, you get only C1e to the -5x. As since it's repeated, the second one is going to be x times. So it's going to be C2x times e to the -5x. This would be your YC. Any question? So make sure you don't miss the repeated solution. Okay, so we need the YP. Bring the R of x, compare. R of x is what? 14e to the -5x. So it's a constant polynomial, okay, times e to the -5x. So the suggestion for YP would be a constant polynomial, okay, constant polynomial with something like a e to the -5x. That's check. Okay, you're checking to see if it's going to be repeated solution. As you can see, there is one. E to the -5x is repeated here. So your YP must be, okay, that's a e to the -5x multiplied by x, but x e to the 5x is also here. So you have to multiply by x squared. Okay, so the suggestion for the YP is a x squared e to the -5x. Any question? If you miss it, when you go back, you substitute, one part of your equation would be all zeros. Because in that case, you just plugging in the solution of the homogeneous equation. So one part of the equation, all of them would be zero. Everything would be canceled out. Then you come back and you recover. Okay, any question? Now, in order to find the A, you have to find again the first derivative, second derivative. Just go back. Be patient, it takes a little bit more time because of the product rule that you have to apply. Okay, there you are. So working on the derivative of this function. So the YP is ax squared e to the -5x. You have to find the y prime. You have to apply the product rule. Of the first, second, second, first. If of the first one, you know, x squared would be 2x. So it's going to be 2ax e to the -5x plus the derivative of the second times first. The second one exponential function never change. U prime would be -5. So it's going to be -5. Okay, it's going to be -5ax squared e to the -5x. Okay, so that's the derivative of the first times second. Then derivative of the second times first. You get the -5. Okay, so that gives you y prime, and you need to differentiate again to get the y double prime. Okay, so yp double prime. Again, both of them you have to apply the product rule. First part derivative of x will be 1, so we get 2ae to the -5x. Derivative of the second times first, you get the -5 times 2 -10 ax e to the -5x. Okay, so that would be derivative of the first one. You have to repeat it for the second one. Derivative of x squared 2, -2, -10, -10 ax e to the -5x. If of a second times first, that is just a -5. Negative would be positive, so that give me 25. Ax squared e to the -5x. Okay, and there is always something that you can simplify. These two, simplify it. So y double prime would be 2a. Okay, 2ae to the -5x minus 20ax e to the -5x and the 25 ax squared e to the -5x. Okay. So you have to take all this back to the original equation, and everything would be nicely canceled out, and then you'll be able to find it. Okay, original equation is this one. Okay, this is going to be your original equation. So I'm going to substitute, starting with the y double prime. What is a y double prime? This is your y double prime. So we are going to have 2a to the negative 5x minus 20ax e to the negative 5x plus 25ax squared e to the negative 5x. It's a plus 10y prime. I'm going to multiply by the way, 10y prime. So it's going to be plus 10 times 220. 20ax e to the negative 5x minus, again, 10 times 5, 50. So that gives 50ax squared e to the negative 5x. That's a 10 by prime. That's 25y. It's going to be plus 25y, and this is y. 25ax squared e to the negative 5x equal to the 14 e to the negative 5. All those coefficients of the x squared, all of them should be disappeared. Otherwise, you made a mistake. Only the one with the constant term. You can divide by negative 5x or simplify it first and then do the job. Okay, both of them would be the same thing that you want to do. Okay, this with the excess, just consider it. This is a negative 20ax, and this is a positive, so these two would cancel out. Always the case. And the x squared must cancel out as well. You have a positive 25, that give you 50, and the negative 50 will cancel out. So the leftover must be only the constant there. So the only leftover is going to be this one. Okay, so you arrive at the 2a e to the negative 5x equal to the 14 e to the negative 5x. Now e to the 5x is never 0, so you cancel it out. So the leftover is going to be 2a equal to the 14. Okay, so a would be 7. That's it. Okay, again, if those terms are not going to be canceling out, probably you missed that duplicating case. Like that. So YP, this is it. So your YP is going to be 7x squared e to the negative 5x. That's it. And the solution is y equal to the YC plus YP. Like that. Okay, so this is the way it's going to be duplicating case, that is the way we are going to operate it. So this is going to be the case that we have. Now, if it's going to be more terms involved, it takes times. I just explained part of the, or let me just explain number 5. In number 5, they ask only for the form of the YP. When the terms are more involved, we don't usually ask for the A. It takes times. And that's, the easiest case scenario. So this is, let's do a couple of from 5. Any question? So it must be a straightforward. If things are complicated, probably you miss something. This is easy case. Now, the other question on this type is we ask only for form of the YP. Look at the expression that we have. Number 5. You ask find a suitable form for YPT if the method of undetermined coefficient is used. Do not evaluate the constants. So you don't have to find the A, B, C, okay? Just do it. So there are a couple of points about these. These are going to be mostly higher one, homogeneous of the higher degree, okay? So let's check number 5. Number 5, for example, part 1. The equation is, this is it, YTR, or the third. 2y double prime, y prime. You see you have a t cubed plus 2e to the t. It's a combination of two functions. It doesn't matter, we pick them each one separately. So we have a polynomial of the cubic polynomial, the first one, exponential function, the other one. So we have to take care of each one of them, okay? But first we have to do the homogeneous, okay? Solution, solve the homogeneous one, which is y tiers minus 2y double prime plus y prime equal to 0. Carefully form your characteristic equation. What's characteristic equation for this one?
R cubed plus 2r squared.
R cubed minus 2r squared. Next one,
This one's R.
that's R. R equal to, those primes would be the power of R. Now we have to solve this one. How are we going to solve it? Factor out R. That's it. So we can handle the inside one easily, okay, or if you like, this is the inside one. So we have R equal to the 0, 1, 1. I'm going to repeat the solution here. Any question? Now I'll write the solution. So YC would be C1 e to the 0, 0x, okay. That's C2 e to the x. Since you repeated, C3 x e to the x. So YC would be C1 C2 e to the x, C3 x e to the x. This is your YC. Any question? Doing the R of x and decide. So we'd like to find the YP. What is R of x? You know, it's R of t, doesn't matter. In the book, you know, they use the variable t, doesn't matter. Type. So R of t is this, t cubed plus 2e to the tt. When you want to write it, you just consider two cases, but we put them together, okay? So this is it, yp equal to the first one. You see, the first one is a cubic polynomial. So you have to write down a cubic polynomial with undetermined coefficients. Who wants to try? Give us a cubic polynomial with undetermined coefficient. Yes.
0.
Make one.
Says A0 plus A1.
A0 plus A1t
Yeah, T. And then
plus
A2 T squared
T squared
plus
plus
A3 T cubed.
A3t cubed, you see?
Boom.
You have to write a general polynomial. Some people, they just change that coefficient of t cubed into the A1, for example. It's not. It's a cubic polynomial. So you have to write the cube. Because you can consider t cubed as t cubed plus 0t squared plus 0t, etc. Okay. Now, you check first. Now, you check to see if there is any duplicated term. Then continue. Is there any of these terms are duplicated here? See it? Constant, very good, but yeah, constant. So the constant is here. So we have to upgrade it. We
Oh.
upgrade it by multiplying by t.
I have a question though.
Yes,
So since this is T cubed plus 2e to the T, do we also have to multiply that polynomial with?
no, we do it one by one.
Oh.
So you do this one first.
Oh, I see,
Yeah,
YP1 and
yeah.
YP2.
Yeah, in instruction, remember I said that if it's a G1 plus G2, your YP would be YP1 plus YP2.
Yeah, I remember.
In action, in practice, if you want to find it, you have to do it by one. Otherwise, you know, it's going to be huge.
Yeah,
Imagine if you want to substitute in the original.
yeah, it's gonna be big.
Okay, so we do it one by one. Any question? Then when you multiply, just make sure that you know it's the duplication is removed. In this case, it's removed because that was constant there. When you multiply by t, the first term will be a0t, so there is no constant there. Okay, now we go to the next one. The next one is what? Exponential function. Is a constant times the exponential function. So you get a constant times exponential function. Okay, you can do something new, or you already got the a3 here, you may go with the a4. So that gives you a4 e to the t. And you have to check. You have to check. I made a mistake, I just call this t, there's a mix up between these, okay? These are all x, okay? Because in this problem, they go with the t. I'm sorry. I usually go with the x, but this is from your book probably. Just want you to see the duplication. Okay, there you are. We check to see if there's going to be anything duplicated. This is e to the t, and e to the t is here. So you have to upgrade it. Upgrade it by t, and you get t e to the t. T e to the t is also here. So we have to upgrade it again. T squared. It's done. Okay, remember they ask only write it down. They don't ask you to solve it. So that would be the end of the problem. Okay, so be careful. You have to solve it to get this result. Okay, so I do one more for you because this one, some people they miss this one part. Okay, I think part C. There is a point about this part C. There is a constant here. I just want to make sure you understand it when you read the solution. Okay, it's a 5C. In the 5C, the equation is this one. Y, the fourth order. Okay, y to the fourth minus y tiers and y double prime, y prime. So look at this one. You have t squared plus 4 plus t sine t. You can make it as complicated as you like, it can be done. You say some people have they just not sure about this part. You can consider t squared plus 4 to be a polynomial. Sorry. Okay, it's a t squared plus 4. T squared plus 4 you can consider as a quadratic polynomial and the other part. Or some people, I gave similar one on the test. Some people consider this one as a t squared and the 4 as a constant. It can be done. But when we write all our constants, sometimes if we apply more than that we need, we change it. Okay, no big deal. Because, for example, you may replace this one by a1. But when you write the t squared, remember you get some 1a1 over 2. So we get a1 and the a5, okay? So it's not a big deal to consider as a true function. Because as a true function, this is 1 and this is the other one, okay? So we have to solve the homogeneous one to see what's going on. Okay, that's it. Y tiers, y double prime, y prime 0. Get the equation, it's going to be r to the 4th, r to the 3rd, r squared, and r. We have all prime. Okay, suggestion, I'm going to solve this one. You can factor out one r out, then decide. So that gives you r cubed, r squared, r and 1. Okay, then we can take care of the inside one. One of solution is 0. Then we can take care of this one. Looping method, factor it. Put out the r square of the first one, then give r minus 1. You need r minus 1, so factor out the negative sign. We have the common factor, so that gives you r minus 1 times r squared minus 1. Okay, so we get 1. This is like r minus 1, r plus 1. So we have a repeated one over here, okay? We should have 4 solutions, so this is it, 4 solutions. We have the -1, 1, 1, and 0. Okay, I factor out this. The signs are all nice, but if it was something like plus, that would be better, but this is what it is. Okay, so this is it. -1, 0, 1, 1. So get the solution, YC. It's gonna be C1 e to the negative t, C2 e to the 0, C3 e to the t, and the C4 t e to the t. Okay,
Professor,
yes.
does it matter which order you put the Rs in? Do they have to be in?
No.
Okay, that was just.
That's fine. Okay, so this is going to be the case. So you know that this C0 is just a constant. C2, C3 e to the t, and C4 t e to the t. So that would be your YC. Okay, you need the YP. Bring R of X and R of T in this case and compare. T squared plus 4 plus T sine T. Okay, as we talk about it, we do it separately. Check this one first. So the YP would be the quadratic polynomial, so you need a quadratic polynomial. Something like A0 A1t plus A2t squared. And you check, as you can see, constant term is here. So we have to upgrade and multiply by t. Okay, we done the first part. In the second part, you have a linear polynomial times sine. So you need a linear polynomial of first degree by the sine and by the cosine. Remember, sine and the cosine at the same time. So we already got up to the A2. So this is going to be A3 plus A4 T sine T. And remember, you have to repeat it for the cosine. Sine and cosine together. Plus, I'll go with the 4. So it's going to be A5 and A6 T cosine of T. And they are not going to be repeated, duplicated terms. So that would be, the final answer. For this group. That's it. Any question? So I posted this practice quiz for you. Okay, it's good for you to practice. You just push it a little bit so that we can finish these terms together. Okay, this system. So after quiz, you can go back to the.